Okay, now we're going to go through the test revision sheet. First question, question 1, we need to find f of 2, and we need to put the 2 where the x is. So f of 2 will equal 2 squared plus 3 times 2 minus 5. We're substituting the 2 in for the x there and there. And so 2 squared is 4, 6 and 5, and so 10 take 5, and so the answer is 5. We're actually finding the corresponding f value when x is 2, and the f value really is the y coordinate. So we could say that we have just found a point lying on that curve which is 2, 5, because that's the x and that's the y. When we do f of minus 1, we put minus 1 where x is. So that's equal to minus 1 squared plus 3 times minus 1 take 5. Minus 1 squared is positive 1. That's take 3 take 5. So 1 take 3 is minus 2, take 5 is minus 7. So effectively we have found another point lying on the curve which is minus 1 comma minus 7. That's the x coordinate, that's the y coordinate, or the f value. Question 2, use factorisation. This is foiling in reverse, so we have to put it into the 2 brackets. The 2 brackets means the 2 firsts has to give the first term here. So that's going to be x and x. The 2 lasts, which are these 2, have to give the last term, which is here. So it's going to come from 2 times 2 is 4. And the bit in the middle term, that comes from the outers and the inners. So this is the first, that's the last. That's why it's called foiling. Outers and inners have to give minus 4x. So that means the only way to do that is if we have minus minus, because the outers, these 2 multiplied, is minus 2x. And the inners, these 2 multiplied, is minus 2x. Minus 2x is minus 4x. So that's our 2 brackets there. And the next one, we do the same thing, put it into 2 brackets. Oh, sorry, I'll just answer the second part of that question, which says use factorisation to find the x-intercepts. So now that we've got it factorised, we need to know what makes it 0, because x-intercepts occur when y is 0. So if we say cut there and cut there, that's cutting on the x-axis. We can see that the y-coordinates of those points are 0. For example, this one could be minus 1, 0. This one here could be 3, 0. They always have a y-coordinate of 0. So x-intercepts have a y-coordinate of 0. So that means we're actually solving this. This is 0. And that'll be 0 when either this bracket 0 or this bracket 0. These happen to be the same brackets. They're going to be 0 when x is 2. And this is going to give the same one. So that's the x-intercept. So clearly it only has one x-intercept. So it really cuts at 2 there, but it doesn't cut there, it actually touches there, comes down and touches at that one point. Okay, the next one, we do the similar way. We have to FOIL it into 2 brackets. And the 2 firsts have to be x times x is x squared, and the last has to be 5 times 2 is 10. To give 7x comes from the outers times the inners, so it's plus 2x plus 5x, which is plus 7x. Now, just like up here, the x-intercept was equal to 2. Here, we're going to get 2 x-intercepts. This one here, that means the x-intercept is equal to minus 5, because if you put minus 5 where x is, then this will be 0. And the x-intercept here is going to be equal to minus 2, because it'll make that 0. So effectively with this one, we're cutting at minus 2 and minus 5, so actually we've got a quadratic looking like that, cutting at minus 5 and minus 2. Okay, next one, we've got a common factor we can take out. So we're going to take out minus 2, and we'll be left with x squared plus 2x plus 1. If you multiply minus 2 through, you'll end up with that original function. And this is easier to factorise now because you've just got the 1x squared, so we can FOIL that. Firsts is x and x, the last is 1 and 1, and outers and inners will give plus 2x. The x-intercept of those two brackets is equal to minus 1, because minus 1 will make that bracket 0 and therefore y 0. So we've got x-intercept there, there and there. This one here, we can't take out a common factor, so this is a hard one. We actually have to have different firsts. To get 2x squared, it's got to come from 2x and x. Now the last could be 1 and 2, but it makes a difference which order we do it in now, because these aren't symmetrical. If we had it 1 and 2, the outers is 4x and the inners is 1x, and that would give 3 difference. But if we did it the other way, we'd have 2x and 2x, which is 4x, and that won't work. So we have to have the top way, not this bottom way. Now to get minus 3x, we have to have the minus with the outside 4x, and the plus 1x with the inside. So it's minus 4x plus 1x is minus 3x. So that's correctly FOILed. Now we have to work out the x-intercepts. And the x-intercept for this bracket is, you can read off straight away as minus a half. Some people might find that a bit difficult to read that straight away. And if that's the case, then you just use this process here. You just actually say, well, let's make that whole bracket equal to 0, take 1 over the other side, then divide by 2. So it's minus a half. If you put minus a half where x is, it'll make that bracket 0. So that's one x-intercept. The other x-intercept is x equals 2, because that'll make that 0. So we have this x-intercept here and this x-intercept here. Okay, question 3, use the quadratic formula to find the x-intercepts of the following. The quadratic formula is this one here. If you have ax squared plus bx plus c equals 0, then the x-intercepts is equal to minus b plus or minus the square root of b squared, take 4ac, all divided by 2a. Now in this case, looking at this one, a is equal to 2, b is equal to 3, and c is equal to minus 5. So using that formula, the x-intercept is minus b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. So that equals minus 3 plus or minus the square root of 3 squared is 9, minus, this is plus, minus and minus is a plus, and that's 40. 2 5s are 10, 10 4s are 40, all divided by 2 2s are 4. So that equals, I'll just give myself a little bit of room here. That's all divided by 4, and that'll come down to minus 3 plus or minus the square root of 49, which is 7, all divided by 4. Now to solve that one, we can treat them separately as minus 3 plus 7 over 4, and minus 3 minus 7 over 4. So if you do this one, minus 3 plus 7 is 4, 4 divided by 4 is 1, and this way it's minus 10 over 4. We could cancel it down to minus 5 on 2. So that's the quadratic formula way of getting the x-intercepts. Doing it in question 2, to get the x-intercepts we needed to FOIL it into 2 brackets. In question 3, you can't FOIL it, so we use the quadratic formula instead. Okay, the next one is a x squared take x minus 8. Once again, we do the quadratic formula. A equals 1, b equals minus 1, c equals minus 8. Quadratic formula is x equals minus b plus or minus the square root of b squared, take 4 times a times c, all divided by 2a. So that's plus 1 plus or minus the square root of 1 squared, which is 1, minus and minus is a plus, 8 fours are 32, and all divided by 2. Now that's 1 plus or minus the square root of 33 over 2. So if we want to put it into 2 x-intercepts, it's 1 plus root 33 on 2 and 1 minus root 33 on 2. And we could go to the calculator or just leave it like that for accuracy. Okay, question 4 and 5 are application questions. This is a roller coaster, x plus 5 and x take 1. State the x-intercepts. X-intercepts is when y equals 0. That's the definition of an x-intercept. So if we put 0 for y, we can see that x equals minus 5 is the answer to making y 0, and x equals 1 is the other answer. So that makes those two brackets 0, so they're the two x-intercepts. To find the y-intercept occurs when x equals 0. So we put x equals 0 into the top. So when we put 0 in for x, we will get y equals 0 plus 5, 0 take 1, which equals minus 5. Now we need to interpret the meanings of these. The meaning of this one here, notice it says in the question that y is the vertical distance and x is the horizontal distance from an observer. So if we've got an observer standing there watching the roller coaster at the origin, so it's like this here, that's the origin, there's the x-axis and there's the y-axis. Then x equals minus 5 is back here, x equals 1 is here. That means the roller coaster at minus 5 and 1 are on the same level as the observer. And the y-intercept being minus 5, that's sitting down here. That's saying that the roller coaster is actually, when it gets to the observer, is actually 5 meters below it, below the observer. So we can kind of see that the function comes down and bends around and back up. So this is the roller coaster here with the x-intercepts and the y-intercept. It does ask us in C to find this turning point here, that one there. To find that turning point occurs halfway in between the two x-intercepts. So halfway in between minus 5 and 1, you just average them. Minus 5 plus 1 is minus 4 over 2, so it's minus 2. There's 1 minus 1, there's minus 2. So it occurs when x is minus 2. That's the x value. To find the corresponding y value, we need to plug that into the formula up above. So y equals minus 2 plus 5, minus 2 take 1. Minus 2 plus 5 is 3. Minus 2 minus 1 is minus 3. So that equals minus 9. So we now know that the coordinate is minus 2 minus 9. That's the turning point or the vertex, and that's this point right here at that cross point. So it cuts on the y-axis minus 5, and it has a turning point -2, -9. Sketch the graph, so we've already done that over there. And then what limitations are there? Limitations are this function here that we've actually plotted. That actually goes on forever and ever up there, and forever and ever up there. Clearly a roller coaster wouldn't go on forever. It would. This is only a section, because it says in the question it represents one section. So it might come up there and then plateau off, and that's where they all hop off, and or it might do another loop or something. But that function only represents that section of the quadratic. Okay, question 5 is a rabbit race. There is the quadratic sitting there. How far has the rabbit run after 2 seconds? Right, that is an x value. X is really the time. So we do d of 2. That's equal to minus 2 squared plus 6 times 2. We replace x with 2. So that's minus 4 plus 12. And so we're 8. So it's 8 meters after 2 seconds. What time is it when the rabbits run 5 meters? So that's the distance. So we put the 5 for distance. So 5 equals minus x squared plus 6x. To solve quadratics, we need to make them equal to 0. I'm going to take the x squared and 6x over the left because I want a plus x squared. So I'm going to add x squared. I'm going to take 6x and I keep the plus 5 there. So that means if I take everything to the left, I've got nothing on the right. I can easily FOIL that into 2 brackets. First out is in as last. 5 comes from 1 times 5. To get the outs and inners to be minus 6, it's minus 5x minus 1x. Solving that equation, we can see we got x equals 1 and x equals 5. That makes those 2 brackets 0. So they are the 2 times. It's at 1 second and 5 seconds that the rabbit has run 5 meters. I mean, if we were to draw this graph, it would look like this when it's 1 second, and this is solving when it equals 5. I'll do that a little bit later. We'll do part C first, and then I'll graph it. How far does the rabbit turn? How far does the rabbit turn before turning around? That should be rabbit run before turning around. So it turns around when it's halfway between 1 and 5, because that's the turning point is halfway between the 2 x-intercepts. But this isn't the quadratic, so it's not 1 and 5, so we have to go back and plot this graph here. I'll give myself a little bit more room. Okay, so plotting the original quadratic, which is y equals minus x squared plus 6x. If we're to factorise that, that'll be taking out minus x. We're left with x and minus 6. So if you expanded that out, you would get the quadratic there. To plot that one, that means it cuts at 0, because that's when it's either this is 0, this bracket, or that bracket. That's 0 when x is 0. That bracket 0 when x is 6. So we've got 6 and 0. This is y, or d, and the x coordinate is x here. This is the x axis. The graph looks like this. It goes up and then comes down. Now we need to know where it turns around. First of all, you can see, if you look at part B, just put in perspective, we asked the question, when does it turn, when is the rabbit 5 meters? Well, if you go up to 5, we found that it occurs when x is 1. If you put 5 across here, you can see we found that it occurs at 1 and 5. So at 1 second and 5 seconds it was 5 meters. We want to know what this value up here is, the turning point. Okay, that's halfway between 1 and 5, which is 3. but we're going to know how far it is. To work out how far it is, we're going to just substitute 3 into the equation. So d equals, using this quadratic, minus 3 squared plus 6 times 3, which is minus 9 plus 18, which is 9. So the coordinate is 3, 9. So this one here is 9 meters, because the coordinate of this turning point is 3, 9. So after 9 meters, it turns around and comes back. Okay, and the back of the question, we had another question that was an activity you do somewhere else.